All right, on to the next. So this is problem number 4. So scores on the quantitative portion of an exam have a mean of 573. So recognize in a lot of these, I'm hesitant to say all, but it's pretty close to all. They always start by giving us a mean and a standard deviation. So we have a mean of 573 and a standard dev of 144. Which makes sense that they'd have to give you a mean and a standard deviation because recognize if you want to know anything about, so if you want to know any one thing about a normal distribution or to be able to extract information from a normal distribution, you have to know where the average is, and then you have to know how big a standard deviation is. So it makes sense that these statistics problems begin by giving you an average and a standard deviation when we're working with this normal curve. All right, so assume scores are normally distributed. Already did that. What percentage of students taking the quantitative exam score below a 587? So what percentage of students taking the quantitative exam score below a 587? Well, what percentage of students taking the quantitative exam score below a 587? Well, think what this is actually asking you. Well, what if the question was, what percentage of students taking the quantitative exam score below a 573? Well, it would be 50%. Why? Well, 573 is your average, so you know half of your curve has to be below. So if this question was, what percentage of students taking the quantitative exam score below 573, the answer would be 50%. So recognize this 587 is more than 573, so we should expect a percentage bigger than 50 because 587 is going to sit to the right of your middle value. So 587 should have more than 50% of the curve sitting to the left. Okay, so we're after this percentage, so recognize what we need to do here. So let's look at our equation. Data value equals average plus z times sigma. Well, what are we given? We're given the average, we're given the standard deviation. Are we given a data value? Well, absolutely, of course we're given the data value. That's this 587. So the data value we are given, and that's the 587. So we can set this up to be 587 is equal to the average, 573, plus z times sigma, which is 144. So we need to rearrange this equation and solve for z, which says take 587, subtract 573, divide the total by 144. So 587 minus 573, all divided by 144, and that is equal to your z-score. Well, why the hell are we solving for a z-score? Well, recognize, once you know the z-score, simply locate that percentile. So let's compute this z-score, 587 minus 573, enter, and then divide by 144. So recognize, with most calculators, I'm anticipating students trying to do this. If you type in 587 minus 573, then divide 144, it's going to think you want to take 587 and subtract off 573 divided by 144. So recognize if you want to push this into your calculator in one step, we need to have the numerator parenthesized. So this gives us a z value of 0.0972 repeating. So now we need to go through our table, find the value of z closest to 0.097. Let's see, I'm looking for z 0.09, z of 0.09, 0.05, 0.1. It's pretty darn close to 0.1. And in fact, we're closer to 0.1 than we are to 0.05. So a z of 0.097 is approximately 0.10. So we need to utilize the z-score that's closest to the one we computed, which is 0.1, which gives us a percentile of 53.98. So this is percentile 53.98. So recognize this says if you got a value, so on the test, if you received a 587, that would land you in the almost the 54th percentile, which means you did better than 54% of the people that took the test. So recognize this is saying 53.98% of your curve sits to the left. So recognize a z-score of approximately 0.1, z-score of approximately 0.1. We're just going to be off the average. So realize just over 50% of our bell curve is going to be to the left when we are 0.1 standard deviations to the right. So hence, we did better than 53.98% of the people that took the test. So what percentage of students taking the quantitative exam scored below a 587? Round to the nearest whole number is needed. Well, we'll round this up to 54. All right, cool. I will see you on the next one.